All right, AP Stats. This is your second question from your assessment retake. So some of you might be seeing this for the first time. So I'll introduce the problem. German researchers investigated the relationship between sugar consumption and strokes. The researchers gave a questionnaire about eating habits to a randomly selected sample of German men. Based on the responses to the questionnaire, the men were classified into two groups, A and B. The researchers tracked the men's health for 10 years. During that time, there were 553 cases of stroke among the men and Group A and 462 cases of stroke among the men in Group B. So our job is to perform a statistical test to see if there is a significant difference between these two groups of men. So with this video, I'm going to show you the 4 steps that AP Statistics is looking for. Alright, we're going to be performing a 2-sample Z-test for this example, but for any test we perform in this course, these are the 4 steps we should take. Step 1, state a correct pair of hypotheses. Now to do that, you also have to state your parameters. So I'm going to use P sub A and P sub B, where P sub A is the probability, or I could use the word proportion of stroke during the 10 years of study for the population of German, the probability of a stroke during the 10 years of the study for the population of German men in Group A, and PB is going to be the probability of a stroke during the 10 years of the study for the population of German men in Group B. So once we have those parameters established, we're ready for the hypotheses. We're going to perform a 2-sample Z-test for the difference of proportions, and these 2 proportions we're going to assume are the same. So that's where I write P sub A is equal to P sub B. So we would say this is a one-sided test because we think that the proportion of men in the first group is going to be higher than the proportion of men in the second group. Alright, step 2, you have to identify the correct test procedure by name or formula, and you have to check the appropriate conditions. So with the test we currently have going on, we have a 2-sample Z-test for the difference of proportions, and so the conditions look like this. The men were randomly selected, so that checks off the random condition. So for the normality condition, all the sample counts are more than 10. Group A had 553 cases with strokes and 8,792 cases without. Group B had 462 cases with strokes and 8,788 without. Since all of these 4 failures and successes are more than 10, the normal condition is met. So a big mistake I see is that students will try to use the central limit theorem on a proportion test, but the central limit theorem only applies when you have a t-test for means. When we have a test that involves proportions, that's when our NP has to be more than 10. Alright, step 3. Correct mechanics, including the value of the test statistic and the p-value, or the rejection region. So what that looks like for us is that once we satisfy the conditions, we are going to list the sample proportions. And so this is where you have to be careful with your notation, right? Earlier we had designated that P sub A is going to be our parameter, but when we look at the actual statistic, we use P hat. So our P hat was 553 people survived the stroke out of 9,250, so that's about 6%. And then the probability of surviving the stroke in Group B was about 0.05. And then with a test, we're allowed to combine those 2 proportions in somewhat of a pooled ratio. So our PC is going to be 5.5%. And then so to show the mechanics, your job is to plug in your difference of proportions and your standard error, and to get a z-score of 2.957, and then the p is the p-value is less than 1%. So to do that calculation on the calculator, I would press Stat, and then test. We're going to perform a 2 proportion z-test. And then what we're going to plug in are the 2 sample proportions. They will calculate the combined proportion on their own. We think that the sample from the 553 is more than the 462, so we want the second. I guess it'd be the third alternate hypothesis. And to calculate this, we can see it's going to provide the PC, and it also gives you the z-score and the p-value. So here's step 4. You have to state the correct conclusion in the context of the study using the result of the statistical test. And so what that looks like for us is that once we calculate a p-value, we're ready to come up with a conclusion. Because the p-value is very small, less than 5%, we reject the null hypothesis. We conclude that the data provide convincing statistical evidence that the German men who would be classified in Group A have a higher probability of a stroke. And so that is one place we need to get better in terms of what our conclusion looks like.